Hi everyone, this is the gas walkthrough for December 26th. I'm Bill Newman. Today I'm solving Battery Death by Bill Murphy. This is a disjoint group Sudoku. So we have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, digits can't repeat relative to their respective positions in boxes. So the example Bill gives, there's a 2 in box 1 in the top right corner. None of the other top right corner cells can contain a 2. And you'll notice there's 9 of these. So if they can't repeat, that means we're going to need the digits from 1 to 9 in these cells. So the top right cells are going to contain 1 to 9, and the central cells, and so on. So those are the rules. We're going to start with some classic. Bill has set us up with some pairs around the grid. So 1 and 2 in this box can't go in these cells. They must go here. 4 and 3 must go here. 5 and 6 must go here. And 7 and 8 must go here. And that's going to leave us with triples. This one is partly resolved. 4 and 6, see this cell, so this must be 5. Up here, 5, 7, 8. I think this continues around the grid as well. 1, 2, and 8, so the 1 goes in the middle. And here 1, 3, 4 with the 4 in the middle. Alright. I think that's most of what we can do immediately with Classic. So let's look at our groups now. We'll start with that 2. 2 can't go in this cell because it is already in the top right corner in box 1. So this must be the 8, and this is the 2. 3 in the bottom right rules 3 out of this cell. 6 in the bottom left rules 6 out of this cell. And then 7 in the top left here. What about these? 1 in the central box. Here we have 4 in the central box, 5 in the central box, and 8. So that's all the corner boxes resolved. So let's continue with the edge boxes. I'm going to fill in the possibilities first, and we'll take a look at what we have here. So in the top row, so this time I'm going to look at them kind of together rather than focusing on an individual cell. We could do it both ways. Where does 4 go in these cells? Well, it can't go in this cell. And there's also a 4 in the top middle, so it can't go in this cell. So this is a 4. 3 can't go in the top right, so this is a 9. So we could have seen that that was a 9 directly from that. But there are other ways of looking at it. In other puzzles, different ways will be more or less useful. The middle here, 2 and 7 are here, so that is resolved. We're left with a 2, 7 pair that's not. And then on the bottom, this can't be a 1, so this is 6, 5, and 1. Alright, this side, 5, 6, 9. We have a 5 and a 6 in the top right. And then we have a 5 here. Here we have 1, 2, 3. That's not 1. This isn't 1, so that's the 1. I don't believe there's a 2 or a 3. Oh, there is a 3 now. So that's 3. That is the 2. 4, 7, 8. Here, 7 goes in that cell, or 8 goes in that cell because that's 7. And 4 here. Alright. At this point we can continue going around like this, but we can also look at the individual groups and see if we can make any progress there. So the remaining digits that we have for the top left are 1 and 2, but there's a 1 here, so we can just fill those in. This one is going to be less restricted, I think. 5, 6, 7, but 5 can't go in either of these. And I don't think we can resolve the 6, 7. This is a 1 now. The 2 makes that 7, 2. And yeah, we could be going about this in a much more systematic way, but at this point, I'm just going to use what I see. So this was a 7 because 9 in the middle on the right. 7, 8. These are 4, 6. 3 here. 2, 6, and 9. That's going to be the 6, 2, 9, yeah. And then here, 3 and 7. 2 and 9. 5, 6, and 8, and 4. That's the solution. So really cool puzzle, really good way of easing you into disjoint groups. Disjoint groups puzzles are notorious for being hard to think about. But Bill has set this up so that you can use Classic in a lot of places to get going and get some digits. And very carefully selected given digits to resolve the entire corner boxes, basically. So really neat puzzle. I hope you enjoyed it as well. Let us know how you did in the comments, and I will see you next time.